Hello, everybody. Thanks for joining us on this webinar that has been organized by IPCC Working Group 3, the mitigation volume of IPCC, and TG-Data, which is the task group on data for climate change assessments, and also with help from IIASA. We are having a session today where the main objective is to present the main outcomes of the IPCC Working Group 3 report, and also show some of the tools that have been developed in the IPCC this round AR6. So to start, we will have Roberto Schaefer from COPPE and the University of Federal of Rio de Janeiro, who's organizing this workshop, and he will be followed by Joana Portugal Pereira, also from COPPE from Rio de Janeiro. Then we will have a video presenting the work being done by TG-Data and the IPCC task group, the technical support unit and the DDC. And then finally, we'll have a demonstration on how to use the Scenario Explorer that's going to be led by Ed Byers from IIASA. So Roberto, please go ahead. And my name, sorry, Sebastián Vicuña. I'm one of the co-chairs of the task group on data for climate change assessments.
Thank you very much, Sebastián. Can you see my slides?
Yes.
Okay. So good morning, everyone, and good afternoon for those that are joining us from Europe and other places. I'm Roberto Schaefer, one of the two CLAs of Chapter 3. And the idea here, in my case, is to briefly introduce you to Chapter 3 and to show you how we have been using the Scenarios Database, let's say, to populate our chapter. So Chapter 3 is about mitigation pathways compatible with long-term goals. And the idea here exactly is to show how, let's say, we have been using this AR6 Scenarios Database in our chapter. Very briefly, I need to tell you a short story here. And the story is that, let's say, we had a very, let's say, sophisticated process of collecting different scenarios, vetting those scenarios, and assessing those scenarios. So basically, we contacted different modeling teams around the world, and we have been able to receive more than 3,000 scenarios. And basically, we did a first screening of these more than 3,000 scenarios that have been submitted, and we selected some 2,266 scenarios that had sufficient information for climate assessment. Then, let's say, we did a further step, which was an initial vetting to try to screen coherence with historical trends and things like that, to make sure that we have a very robust set of scenarios. So we ended up in some 1,686 scenarios, and we used those scenarios for a climate categorization. And then I'm going to show you later, we did a further screening of those scenarios to select what we call illustrative pathways, which would be a way to represent such a large group of scenarios into more representative scenarios. What's important to say here is that we have more than 190 models represented in this database, 91 global models, 71 national or multi-regional models, and also some 20 sectoral models. But once we have this huge database, we had been able to categorize or classify those scenarios according to different temperature categories. So basically, we split all scenarios into 8 different categories, where C1 is the lowest category, with limiting warming to 1.5 degrees with no or limited overshoot, and C8 was the highest category where we had exceeded warming above 4 degrees. And basically, this was used all over our chapter and in many other chapters in the report to try to classify those scenarios into temperature categories. As I mentioned before, let's say once we have these 1,686 scenarios, we decided to do an extra vetting to select what we call illustrative pathways. And basically, we selected 7 illustrative pathways, 5 of which we call illustrative mitigation pathways. And basically, we select, let's say, 2 scenarios, a current policy one and a modern action one. One represented a C7 temperature, which is roughly 4 degrees. Another one representing a C6 category, roughly a 3-degree scenario, very much in line with, let's say, with the pledges of the different NDCs. And then we selected 5 illustrative mitigation pathways. One, GS, associated with C3 temperature, which is basically 2 degrees. Another one, the NEG, which is a C2 category, roughly a 1.5 with high overshoot, and then the REN, low demand, and SP, which are C1 categories or 1.5 with no or limited overshoot. And this was very useful for us to try to explore different possibilities for mitigation, since the IPCC is not supposed to be prescriptive, but basically describe what is in the literature. Very briefly, this is, let's say, the kind of information we try to collect or represent with these illustrative pathways. So we see here, let's say, the behavior over time of emissions up to 2100, let's say, current policies, which is a C7, modern action, and then the other IMPs. So we see different possibilities and different profiles of emissions. The same applies when we try to translate those illustrative pathways into the energy system, let's say, discrimination. So we see here, depending upon which scenario we're talking about, or which family of scenarios, we see the role, for example, of fossil fuels, biomass, renewables, nuclear, etc., etc. So this was very useful information for us to explore in our chapter, but also in the report as a whole. Going a little bit deeper into the scenarios that we have been able to select. So basically, let's say that the most representative scenarios from different model families are shown here. So we have different models represented, some of them with more scenarios, others with less scenarios, but it's a pretty good, let's say, kind of, let's say, diversification of sources or scenarios or models to represent in our database. When it comes, let's say, to each research project that was behind those scenarios, you also see, let's say, some projects, some EU-funded project like Engage, for example, having a very large number of scenarios, but also other projects from different places also being well represented in this database. Regarding the number of scenarios that we have been able to collect according to the different climate categories, we see, let's say, a number of C1 scenarios, a number of C2, C3, etc. And in the case of chapter 3, we try to concentrate most of our analysis into C1, C2, C3, because we had a kind of interpretation that C1, C2, C3 were the categories more in line with the Paris Agreement. And then we had been able, let's say, using these categories of temperature and also these thousands of scenarios in the database, we had been able to, let's say, to make explicit greenhouse gas emissions by temperature category, emissions milestones, cumulative emissions, temperature outcomes. So it is an extremely rich database that was only possible because we have been able to receive so many scenarios and we have been able to classify those according to different temperature levels. And then also we have been able to explore, let's say, emissions by regions, depending upon which temperature category we're talking about, also because of this rich database. And for example, since this seminar is more devoted to Latin America and the Caribbean countries, we see, for example, Latin America and the Caribbean well represented, let's say, in these figures. So let's say, to finalize here, basically what I have to say this was truly a 3-year collaborative journey. Let's say we had a call for submission of scenarios, we have submission and compilation, we have verification of completeness and validation of those scenarios. We put those into the repository of the IPCC, and now we have, let's say, a tool to explore this repository, and Ed Byers later on today will explain us how to explore that. So really, let's say, a rich work that was done here, let's say, really a accomplishment. So we are going to see more of that in the continuation of the discussions today. Thank you very much, and let me stop by here and then pass the word to Joanna. Thank you very much again.
Thank you, Roberto. I'll try to share my screen now. I hope you can see my first slide.
Yes.
Perfect. Thank you, Roberto. So hello, everyone. Good morning, good afternoon, wherever you are. Thank you, Sebastian, for the kind presentation. My name is Joanna. I'm an assistant professor at the Energy Planning Program in COPPE at the Federal University of Rio de Janeiro. And I'm delighted to be here and discuss with you the further developments we did in AR6 in the 6th assessment report to touch upon national and regional pathways for climate action. So I'm here following Roberto's presentation on chapter 3 that focuses on global and long-term mitigation scenarios. I'm here to discuss with you and key findings from chapter 4 that focus on near and mid-term mitigation pathways and implications and correlations with development. I would also like to call your attention to Annex C, that is entirely dedicated on scenarios and modeling methods, where you can dig into scientific jargon and key findings and details and of the assumptions and implications of the overall scenario and modeling developed in this report, not only at the global and national scale, but also at sectorial. So it also involves chapters related to each sectorial aspect of the report. So while in previous IPCC assessments, the focus on scenarios was mainly on global scale and long-term implications, as presented by Roberto in chapter 3, there has been a growing interest and literature available that touch upon national and mid and near-term implications of mitigation. So something unique and original in the 6th assessment report was to include, in addition to global mitigation scenarios, an entire chapter dedicated to national and country level assessments. And that was very challenging because we had a big dispersion apologies, of literature, and also because one of the core aspects of IPCC is to be policy relevant and not policy prescriptive. Even though in chapter 4 we developed a more bottom-up analysis and we evaluate specific policies from regions and countries. So what we see here on the left-hand side is a figure that we call the emissions gap. We show here 4 different trends. I hope you can see my pointer. In the red one, we see the greenhouse gas emission trends that reflects current and implemented policies, while we see different mitigation trends. The purple one that reflects the NDCs, the National Determined Policies, has submitted and announced it in COPPE 26, which reflect a late climate action in comparison with the green line that shows immediate actions that could take us to a global warming of 2 degrees, and in the blue, a more ambitious pathway that reflects ambitious required to reach 1.5 global warming by the end of the century. So what we see here in this figure, under current NDC pledges and current policy, it's very likely that we will reach 1.5 global warming by this decade. And at the current state of affairs, reaching 2 degrees Celsius pathways is becoming challenging since we are not acting fast and speedy enough as required. I'll just move this animation. Besides the NDCs and the bottom-up analysis, we also evaluated, as I just mentioned, policy assessment, and that brings us to different gaps available. We have the emission gaps, that is defining as the difference between the trend for implemented policies, as marked here, and what would be necessary if we want to stabilize global warming well below 2 degrees and 1.5 to fulfill Paris Agreement long-term temperature goals. And we also evaluate what we call the implementation gap. That's the difference between the announced policies that will be able to support the pledges of NDCs. And if we consider that, the emission gap in the implementation can vary between 4 to 7 gigatons of CO2 equivalent, depending if we are talking about conditional or unconditional NDCs. So to reach the Paris Agreement goals, we conclude we need to increase our ambition and reduce greenhouse gas emissions by 40% during this decade and reaching net zero by 2050 in terms of CO2. So also in chapter 4, we evaluated what we call investment gaps, and here I highlighted the region of Latin America and Caribbean. Traditionally, we know there's higher investments in the global north, and we are far short in our region in terms of climate mitigation investment gaps that must be scaled up to 4 to 8-fold if we want to take seriously the Paris Agreement goals, and this should happen during the current decade. In terms of assessments, models, and scenarios analyzed in AR6 by chapter 4, I highlighted here what has been developed for Latin American Caribbean region. In the left-hand side, we can see the number of assessments that has been reported and evaluated by the chapter. I discriminated by global assessments, national or official government assessments. And 2 key messages I would like you to take here. Firstly, it's not surprising given the dimension of countries that Brazil, followed by Mexico, are the countries in the region better represented. And also, there's more assessments with models at a global scale that see the countries or the region integrated with a global perspective. So here, while the Latin American Caribbean region is well represented, there's a lack of national assessments that could dig into more details and specific context from the region. So based on this analysis here, on the right-hand side, we can compare the emissions from the bottom-up analysis for the countries selected here, considering current policies up to 2030 and unconditional NDCs also for 2030. And that's integrates and connects with chapter 3 that has a global scale perspective. And here in chapter 4, as I mentioned earlier, we focus on a bottom-up policy analysis at a more granular level. So in terms of long-term strategy, the LTCs submitted in the region, we also evaluated for several countries, and here I have a screenshot of one figure that you can find in chapter 4 and related tables, where up to 2021, so I'm afraid this is a bit outdated given the current evolution of announcements in the latest COPPE, and what is to come this year. We see Mexico, Colombia, Brazil, among other countries, Chile as well, other countries in the region has announced their LTC strategies to mid-century. And in the figure, we see there's a clear difference between what we see marked in yellow here, what we call the baseline or the current policy trends, compared to NDCs and to long-term strategies. So in terms of the database, that will be further detailed by Ed and Ala following my presentation. I would like to highlight the national integrated assessment models that are part of the database. And here again, I highlighted what we can find for Latin America region. We have integrated assessment models with a national focus from Brazil, from here, COPPE, my team led by Roberto. We see also models to Mexico, Ecuador, and Chile. So I invite you to dig into the data that will be presented later on by Ed and Ala. And that's everything from my side. Over to you. Thank you.
Thank you, Joanna. I think Ed, it will be time for showing the video on TG-Data now, DDC and the TSU.
Thanks, Sebastian, and hello everyone. So my name is Ala Kurdaji. I'm from the Technical Support Unit of Working Group 3, and we will show you now a video that covers the work of TG-Data that took place during AR6. It will also introduce one of the data distribution centers that worked with Working Group 3, and this data distribution center is called Metadata Work. And then you will hear a recorded presentation from me as well on how we implemented the FAIR data protocol in Working Group 3. So I'm going to share my video in 1 second. Okay, I hope you see my screen.
Hi, my name is WR. I co-chair with Sebastian Vicuña the IPCC task group on data support for climate change assessments, TG-Data. And our objective is to improve access to IPCC data, both for IPCC authors and also for scientists who rely on the IPCC reports. So this presentation is just meant to give you an overview of the efforts that we made in AR6 to make IPCC data more accessible and reusable. And the work relies heavily on the IPCC data distribution centers, so the DDC, and the technical support units from all 3 working groups. So I'll just be introducing TG-Data briefly, and then Adam will present the DDC and its data curation activities, followed by Ala with the role played by the working group 3 TSU. So the task group on data support for climate change assessments was created in 2019, and it takes over from the previous task group on data and scenario support for impact and climate analysis. So this previous group was created in 1997 to provide regional climate change information, and it published various guidelines on socioeconomic scenarios, greenhouse gas scenarios, sea level scenarios, and also statistical downscaling. Now, TG-Data is focused less on creating these types of guidance material and more on data access and reusability. And so our mandate is really about putting data out there. So our objective is to make sure that the IPCC data follows the FAIR principles, meaning data should be findable, accessible, interoperable, and usable, reusable. This applies both to the data assessed by authors as to the data created by authors to prepare graphics and tables within the report. And so to achieve this, we've been working with the DDC, a network of institutions that generously contribute their expertise in data creation to the IPCC. And one of the reasons why we want to do this is that there's an enormous amount of work that goes into the report and its review. Just to give you an example, in AR6, over 180,000 comments were collected for the first and second drafts of the 3 working groups. And each and every one of these comments was given a response. So really the data that analyze all of this deserves to be highlighted and made available so it can be used as a starting point for further research and analysis. So our main objective for the 6th cycle is to publish and archive the data underlying figures and tables found in the summary for policymakers and the technical summaries for all 3 working groups, as well as the synthesis report. And so the DDC is also working to preserve a snapshot of the core CMIP6 and Cordex data used by IPCC authors in the assessment, this emission scenario database, as well as other key biophysical and socioeconomic data sets that are assessed. And so archiving and publishing those data sets requires an enormous amount of work and coordination distributed among AR6 authors themselves, the technical support staff, and the data distribution centers. And so now I'll let Adam present the DDC and its data creation activities. Thanks.
Hi, I'm Adam Millward from Metadata Works, and welcome to my talk on the IPCC Data Distribution Centre. So to support the most important decisions of our generation, governments, journalists and citizen groups all need access to credible, relevant data on the causes, impacts and effective mitigation strategies for climate change. An enormous amount of data is generated for climate change research, and it's an incredibly valuable asset. So distributing and preserving that data ensures the full value of the data is maximised, and that's what the DDC is all about. In terms of our history, well, we know that trust, openness and transparency are fundamental tenets of the IPCC activities. So the DDC was established in 1997 to ensure the provenance and traceability of all of that data and to ensure it would be high quality and accessible to researchers across the world. They've also been established to support the provision of data and to provide tools and guidance for all the IPCC authors, editors and coordinators during each assessment cycle. In terms of our principles, we sign up to the FAIR data principles. So it's all about findable, accessible, interoperable and reusable data. And I'd encourage you to come and read some of the documentation we've got around that. We also sign up to the trust principles around data preservation within data environments. We sign up to DataCite's principles around digital object identifiers and archival. So what does that look like in the real world? Well, it's all about traceability, credit and preservation. So if we're looking at one of the assessment reports at the moment, let's say the summary for policymakers for Working Group 3, there'll be a number of different graphics. And let's say that figure SPM4, which is all about global GHG emissions, was interesting and we wanted to dive into a little bit more detail. We can then transfer over to the IPCC data catalogue and we can go and explore the data itself that supports those final figures. So there's 4 different panels, there's 4 different data sets. We can go and download them, explore them and understand the context of that data. That final figure data is an analysis of other data, other source data. And so that final figure data references those different sources. So the catalogue also then provides the traceability and credit for those different sources, such as the IIASA data or the Copernicus data as well. And all of this ensures that the data is preserved effectively so that it conforms to the principles of fairness, findable, accessibility, interoperability and reusability. In addition to providing the data catalogue and all of those preservation services, the DDC offers a support desk for the public so they can come and ask questions, and there's an interface to the DDC team. And they can also interface with authors and editors and coordinators through that platform. We've got a really good customer satisfaction rating through that capability. We also provide a metadata onboarding platform within the data catalogue. So this is a secure area where coordinators can come in and tell us about all of the data that's coming through the assessment reports. And we've got a metadata profile that describes exactly the type of information we would like to capture when we're preserving, we're archiving data to make it more findable through the data catalogue. If you're interested in that, I've put some links in the resources slide at the end of this presentation. In terms of the opportunities going forward, well, we think there's an opportunity to support increased data access and usage through the platform and through the services we offer. We want to fill in the gaps in some of the IPCC data archival processes. We think we can improve the quality and efficiency of data management for the whole IPCC and provide leadership and best practice, such as the metadata profile that we've published on GitHub. We're also looking to enhance some of the catalogue features, so we're going to be creating collections to bring all of the different data sets together. We want to create a bit more of a dynamic user interface where we can preview some of the content and also create a space where events can be published. So if someone's created a webinar like this to talk about the data, that can be displayed alongside the data itself and be available to different type of consumers. We're also looking to enhance the service, so increase the coverage of input and intermediate data sets during the next assessment cycle. We're looking to develop some user-friendly visual overviews that describes the relationship between data sets and organizations across the IPCC. And also we're going to look at establishing federation that will allow different data repositories to talk to one another and start to share the metadata to improve visibility and accessibility of the data across the IPCC. So in terms of the resources, I'd encourage you to come and look at IPCC data and search for data sets. We've got some schemas on GitHub if you're interested in metadata profiles, and also if you'd like to learn more about us, please follow the links below. Thank you very much for listening.
Hello everyone, my name is Ala Kurdaji and I'm Senior Scientist at Working Group 3 Technical Support Unit. Today I'll be describing to you the role of the TSU in supporting the TG-Data process and the use of data in our underlying report. The TSU is overseen by the Working Group Bureau and works closely with the TG-Data group in order to ensure the implementation of the FAIR data principles. As you well know, in addition to undertaking the assessment, our authors also produce data and figures to support the assessment. And to give you an idea, in Working Group 3 AR6 report, we have around 320 figures. The role of the Technical Support Unit is to provide guidance and training to the authors, as well as figure and data management. And we are also in the process of produce a GitHub repository that include the underlying data of our SPM and technical summary figures and some of their input data. We also work closely with our colleagues at the Data Distribution Center who set up a Zenodo AR6 community, and we provided them with the underlying data for some of our SPM and TS figure as well as their input data. We work closely with the Secretariat in order to ensure that all queries related to figure use are addressed. We work with the data distribution centers in order to ensure the quality control of the implementation of the FAIR data principle in our report. Just a reminder to everyone that the IPCC does not produce its own data, but rather reproduce data available in figures or post-processed data from existing data sets available in the underlying literature. One of the major data products for the Working Group 3 AR6 report is the AR6 Scenario Explorer and database, which is hosted at the International Institute for Applied System Analysis in Austria. So the FAIR data principles are there to ensure that the assessed data code or analyses used to produce figures and tables in our report are properly documented and curated to allow traceability and stability as well as transparency of the assessment. These principles also support the implementation of the IPCC error protocol, which is used should an error be found at a later stage. As for the implementation of these principles in the Working Group 3 AR6 report, they have been implemented on all summary for policymaker figures. They have also been implemented on the technical summary figures and some of the input data sets for these figures. You can find all archived data for the AR6 assessment in the AR6 data catalog, which I provide the link for here. As for working group 3, SPM and technical summary data and figures, they can be found available in the MetaDataWorks Data Distribution Center catalog, which I provide the link for here as well. And for each of these figures, we do not only provide the data, but also the metadata, the abstract and citation, as well as information on the derivation of the underlying data and the recommended figure citation. And as I mentioned earlier, we worked closely with our colleagues in the DDC on the providing data for the Zenodo AR6 community. In terms of licensing, IPCC post-process data and figure data are distributed under a Creative Commons Attribution license, as long as this does not infringe the interest of relevant license holders. We made this recommendation in order to facilitate the reuse of the data both in research by practitioners, the media, and users more broadly. In terms of copyrights, the IPCC assessment product, be it text, logos, maps, or electronic downloads, is a property of the IPCC, are protected by intellectual property laws. You may download, copy material for personal and non-commercial use. A limited number of the figures or short excerpt of the report can be reproduced for books, for instance, and there is no charge for this use as long as the original source is properly acknowledged with full citation, be it the chapter or the SPM, and full legend. Any queries regarding reproducing IPCC material can be submitted to the IPCC Secretariat. So to summarize, the AR6 established TG-Data in order to strengthen the collaboration between the DDC and the TSU on the implementation of the fair data principle for the first time in the IPCC. Now that we are in the last few months of the AR6 assessment cycle, TG-Data will be debriefing on the experience in the AR6 with the DDC, TSU, as well as authors to provide recommendation for future cycle. And this is a key step for the implementation of the FAIR principles immediately at the start of the next assessment cycle with a strong collaboration across all parties, as well as establishing a direct link between contacts in the TSU, DDC, and TG-Data from the start. Thank you.
Thank you. Well, Alain, the group that produced that video. So I think it's now your turn, Ed.
Sure. Thanks, Alain and Sebastian. Okay, so good afternoon, everyone, and nice to see you here. Welcome to this demonstration of the AR6 Scenario Explorer and Database. I'm going to run through a number of the features, and this will also be recorded so people can watch afterwards, and we have documentation available, and we'll have a little bit of a focus more on data that's available from Latin America and Caribbean region. Just hoping you can see the right screen. So you can see the screen with the web page, I hope. And so to access the database, we go to data.ene.iasa.ac.at. We don't need this bit, / AR6. And here we get the, oops, I'll just go back, the login page. We can access the database as a guest, but there are benefits to logging in or creating an account. And so If you log in and create an account, which you can do here through the registration button, you'll have access to multiple scenario explorers through one account. So not just the AR6 database, but also the one from the 1.5 degrees IPCC report, NGFS, which are the scenarios used by central banks in the finance sector, and others from projects. You can also save databases. You can also save workspaces so that the configurations that you make can be accessed later and share them with other people. And you can also access the downloads, which might not always be available depending on which database. In order to register an account, you can click to register, and this is a very simple form that you fill out, and you'll receive the instructions via your email. Otherwise, we can log in and we get to this workspaces tour. This purple box will actually take you through some of the features, but I'll skip that for now. And this is the workspaces page. And here we see lots of different panels that you're available to customize. Each workspace is like a customizable dashboard developed by a user and comprises different panels, and each panel is a chart of data, and you can create and save multiple workspaces and explore the data, and you can share these workspaces with other people. And so here, for example, we can see examples that were made after the AR6 report for the illustrative mitigation pathways. So one about final energy, another one about greenhouse gas emissions and climate outcomes, and also about primary energy and secondary energy. The illustrative mitigation pathways were these 9 scenarios chosen in the Working Group 3 report because they're particularly unique and also high quality, and they're introduced in the summary for policymakers and also Chapter 3. They show different characteristics such as low demands or high efficiency or lots of renewables, and they are primarily shown in these workspaces at the global level, but they do have data available at the regional level. We also have 2 workspaces created specifically for this session based on Latin American Caribbean data. And so we can also see ones that were made for other regional workshops. So for example, this Europe one here, one about New Zealand. But I'm going to go to this first one, Latin America 1.5C pathways. And we click open here, but I've got it open already. When we open the workspace, we can see different panels of data. So this is like all good TV chefs, one that I made earlier, because it does take a little bit of time, but I'll show you how this is built up. And this specific workspace compares key variables from what we call the C1 pathways for Latin America and the Caribbean. The C1 pathways come from global integrated assessment models, and they're the pathways that limit global warming to 1.5 degrees or lower with no or low overshoot. In terms of scenarios that come from global integrated assessment models, the benefits are that they're globally consistent. They tend to be cost optimization models, and they have a wide coverage of both energy and land use system emissions. So they cover everything required to model climate response, but they may be limited in terms of specific national resolution or sectoral details that we had in more detailed sectoral models. What we're showing on this page and panel is a multi-model scenario comparison. And so this is good for understanding lots of different outcomes from scenarios that are consistent in limiting warming to 1.5 degrees, and they come from different models. Models don't always agree on all aspects. Diversity of outcomes can actually lead to useful insights. And here we see that we have 97 scenarios that are in this C1 category. And so out of about 1,200 global scenarios that were used that had a, let's say, a climate categorization. And these are the 1,200 scenarios that feature in various parts of the summary for policymakers. These C1 scenarios are consistent with 1.5 degrees, and we've got different panels based on carbon sequestration, secondary energy for the electricity sector, methane emissions, and CO2 emissions from energy and industrial processes. So we can see, as we might imagine, a fairly not too drastic growth in energy industrial process emissions through the content, because this is a more low emission scenario, but certainly not reductions. Methane emissions across all the scenarios tend to be gradually reducing. Carbon sequestration, also a very wide range across the scenarios for Latin America. And so those may be scenarios that either depend a little or quite a lot on CCS or bioenergy and carbon capture and storage. Electricity generation also growing from perhaps around 4 or 5 exajoules per year, perhaps even a 10-fold growth. CO2 emissions from electricity supply reducing more drastically, and also final energy demands increasing. These data range from a wide range of different types of models. In fact, in AR6 we had more than 100 different model families, many that had not participated in the IPCC process before. But most of these results coming from integrated assessment models. It's also important to note at this point that different models and different scenarios report many different numbers of variables. So the data that's available from one national model from Southeast Asia may not be reporting all the same variables as another model from Latin America, or a different type of model. Some of the models are focused just on the energy system, and so they're reporting primarily energy system and also CO2 emissions. Others are more sectoral, such as for buildings, transport, and land use, and they're reporting different types of data related to those sectors. So now we'll go through the panels to see how we can customize them and see what's available. So for example, in this top one, we have these gray buttons, and we can see what these, yeah, my apologies. I've just realized I changed something. So I thought we were showing the emissions, but we weren't. We're showing the carbon price, but we can change this here. So if we want to change the variable that's being shown, we're going to click here on variables, and we're going to show the emissions that it should have been showing. And so the variables have a kind of a nested tree type structure. So we can browse it like this. And this is the one that it should have been showing. There we see reductions. So here we can see reductions in energy industrial process emissions. And consistent with the 1.5 degree pathway, they are reducing and even going net negative towards the middle of the century. We can also change the region. So if we click on the region, we've got Latin American countries. But in this drop-down box, we can see different groups of different types of regions. So if we have scenario global, we can choose to see what the global data looks like. Different models have different resolutions of regional data. And so the coarsest models have data at this R6 and R5 region. And so we were currently looking at Latin American countries. This is from model data that is collected just for these 6 global regions. Some models are able to report at a higher resolution. And so here we have a 10 global region, and some models report data also at the country level. So I'm going to change here and I say, well, I wonder what this data looks like for North America and Canada. Remove that one, click apply, and here we see exactly the same scenarios, exactly the same model runs, but is the data for North America and Canada. We can also change that for the global emissions from the same scenarios, and we see that this is what the global emissions profiles look for here. You will have noticed also that we have the full list of global countries here, but this is not necessarily all models have reported data. In fact, most models haven't reported data for most of these countries, but that is a way of searching for country level data. We need to select the region first in order to know what data is available. So I'm going to go back here, and we can then go to data selection. And so here we were showing energy industrial processes. Another example, let's say if you're interested in carbon price, we can just search also by text the variables, and we'll see the variables that match this. So variables on carbon intensity, carbon sequestration, utilization, and price also. So I'm going to choose this carbon price one, click apply, and the data gets queried and shown. So that's the first graph that we looked at. Along the top, because this list of variables is very long, we can also use some filters. So variables specifically on socioeconomics are these ones. On energy, we can see these ones. Some specifically on emissions or the climate assessment in terms of what's coming out of the climate models. Then we can see the variables that are available. As I said, not all variables are available for all models. And so something that's useful to do is also to click this button, show only available variables for the scenario selection. So since we've selected models and scenarios, then then we'll only see variables that are available for the specific model, scenario, and regional selection. And this is an easier way to filter that down. So I'll just go back to the carbon price. Okay. We can also change the visualization and the way that the graph is shown, and that's through some of these options here. So we can change both the extent in terms of years that is shown. So actually we see this data goes out to 2100, but maybe we want to focus it to this period, near-term carbon prices. We can also change the panel name, the description. We can change to display as a bar chart or a table. There are other visualization options here in the top right. So this one here, for example, will toggle the legend on and off. As I said, we can change the chart style, so we can make this into a bar chart. It doesn't make sense for this type of data, but I'll show you later. We can also view the data as a type of a table, and I find this a really useful function for getting an idea of which of the models and scenarios that are featured in this data set. Perhaps maybe it's better to download the button, and we can click that button here, and you have the options to download it as either as a CSV or an Excel format. And this is useful also just for downloading a small snippet of the database for working on your home computer. We can also make the panel larger if you want it as a, let's say, a full widescreen or smaller. And then we can also clone this panel. And so it can take a little bit of time to configure these different dashboards. And so if we clone the panel, then we can copy all those settings and then just change a small feature. So for example, here we've got the GDP projections. I clicked clone. It appears here, exactly the same configuration. And then I decide that we just want to change, let's say, the region. And then we'll change that one to Sub-Saharan Africa. And then we quickly have our comparison. And I do this because it saves a lot of time. Okay, this is a good moment for a break for questions. I'll just see if something's been coming. I think colleagues have been able to answer most of the questions as we go, but if anyone has any quick questions they want to ask now, or if there are any questions that weren't, I'll just have a quick look.
I see it that Ilker Inmes has her hand up. I'm not sure if he already put that question in the.
Let's see. I don't see the question.
No, all questions have been answered, I think. All the
Okay.
one that went.
I can't see the raised hands either, though. Okay. Maybe we'll. Okay. I think we'll keep the questions to the Q&A section, though, and hopefully these get answered during the session. So I'll continue with the next bit. So now we have another workspace that I was working on configuring before the session. And this is the one that we called Latin American Caribbean example models. So some of those models that Joanna introduced in her presentation a little bit earlier, such as Imaclim and Blues Brazil, we can see and how to extract specifically the data for those models. As mentioned, yeah, some regions have submitted more national model level data than others. So for example, in Southeast Asia, there are a number of countries that, or research institutes that submitted data from national level models. From Latin America, we were fairly limited in terms of Mexico, Brazil, Argentina, and Ecuador, if I'm not mistaken. But I hope that we can get the ball moving and have more scenarios in the future from also Latin America studies that will inform national assessments for the NDCs. And so in this example here, we're showing the table. I actually did a search through the database to explore, because some of the models are national level models and they've submitted data for Brazil and Argentina. Some of the global models also report data for specific countries. And so I've done a search through the database to see what's available. And we can see some of the models and some of the scenarios like AIM, COPPE, GCAM. These are global models, but they report data for specific countries such as Brazil and Argentina, GEMI3, Image, and WICH. Now I've only chosen these three regions, but we may find for other countries also. So we could try even Mexico, and let's say Chile. I've sort the data by region, and we can see, okay, a number of countries, a number of models are also submitting data for Mexico. This is for the emission CO2 energy variable. And it will depend on each variable in each region what's available. Here I've done a comparison of the IMACLIM Brazil and the BLUES Brazil models. I've only chosen 4 scenarios, although there are more available, and we can see that we can do a multi-model comparison, but just for 2 different national models. And so we see the emissions in the order of 350 megatons per year for the Brazilian energy sector. Similar graph, but here including the MSB model, which is also from COPPE for secondary energy electricity production. Again, carbon sequestration, comparing the 3 models, IMACLIM, BLUES, and MSB. And so we see most scenarios wouldn't predict much carbon sequestration with biomass, but there are some scenarios from the BLUES model that do project a large growth in carbon sequestration, or what we call BECCS, bioenergy with carbon sequestration. Different projections also for carbon prices. And lastly, also we have the ELENA Ecuador model. So they submitted 2 scenarios, and this is also a full sector, so it includes energy sector emissions and also full CO2 emissions for the country. So we have 2 scenarios, so one that's called DDP high and one that's called MIN-C. So this is probably more along line current policies. And lastly, I've chosen the final energy. And so this is an example of a different type of graph. We've actually selected 6 variables here. So I thought, how can we understand the structure of the final energy sector in terms of electricity, gases, geothermal, heat, solids, and liquids? And so we can choose those. I would show you here, final energy. Select these different components of the final energy. Obviously, as a line graph, it doesn't make sense. Although we have this, it's for 2 different scenarios. And so we can select bar chart, and there's this button here to toggle a stacked chart. And so now we can compare the structure of final energy for these 2 scenarios. If we remove one of the scenarios, if we remove one of the scenarios, then we can also have it as a stacked line chart, which might be also familiar for some people. Lastly, this is a good example to show the documentation button. So this button here, I didn't show this one. Yeah, this button here shows us the documentation. Different models submitted different amounts of information about themselves, but here we can see, get a quick introspection of information that's available about these models that are shown in this panel. And so I can click here, and I see for BLUES Brazil, there's nice information about the model objective. BLUES Brazil is development expansion of Message Brazil model, optimization model with objective of attending demand with the lowest cost. And then there's a link to the model documentation, and we can see that it's coverage of the Brazil region only. We can also see which are the scenarios that are available. And so, for example, the scenario, we don't have a detailed description, but we've got a link that goes directly to a paper published in Journal of Energy Policy. And then a different scenario actually has a description. Business as usual scenario, including climate and energy policies, extended to 2100. So we can really quickly see information about these scenarios by clicking here. Not everything has information about it, depends what was submitted by the teams, but we've tried to make this as complete. Lastly, I'm going to go through the selection of different scenarios. This is where it gets a bit more complicated if we're going to build a new workspace. And so there's two different ways of selecting scenarios. One is using what we call category and indicator information, and one is by a specific model scenario list. So if we're selecting from the list, we need to know what are the models and the scenarios that we want to explore. I wouldn't recommend clicking add all scenarios because this can bring in all the data from the database and cause problems. It takes a bit of time and it won't necessarily be useful. So if we know what we want to select, we can use this select from list, and we can filter by the model name. And then you see the list of scenarios, or you could filter, for example, let's clear that. You could filter and say, I'm interested in SSP1 scenarios, and we see all the scenarios that have SSP1 in them. In terms of the metadata that we have in the database, we can also select by different categories. It's just loading for a second. And so this data that's gone into the database is not just time series data, but information that was submitted by teams or added by authors in the assessment is also able to search. Maybe I go for this one here. Okay, so focusing on the right-hand side of the screen here, the main filter that we can see for searching for scenarios is called the regional scope, and so it indicates if the regional coverage is global, multi-regional, or national. So you can say, well, actually, in this case, I'm only interested in global models, perhaps now. And so then we see that there are 2,299 global scenarios in here. And then we could actually, and so, oops, just wait for it to update. And so now we have 2,299 scenarios selected. But maybe I want to filter by some extra characteristics. So for example, Roberto introduced the concept of a climate category earlier. And so if we want scenarios that have a climate category name, we can select this one. It takes a little bit of a moment. And so then we will have the option to select, for example, only low emission scenarios or only high emission scenarios. This loads the different filters. I'm just going to clear that. And then we want to say, well, I'm interested in C1 scenarios. These are the most ambitious climate scenarios and maybe 2-degree scenarios. So interested in these low emission scenarios. And then we would click apply. There's also many other different filters, and you can add multiple of them. So for example, we've also introduced the illustrative mitigation pathways, which are the 9 kind of iconic scenarios, and we select this one, which is IMP marker. And this would give us a selection of just 9 scenarios. Also, many of these other categories that you can see in here are either numerical or categorical data. So these are 9 illustrative marker scenarios. So for example, if you knew that I want scenarios that reduce greenhouse gas emissions between 2019 and 2050 by a certain percentage, then we can filter the scenarios by this specific numerical range. And so we can say, well, I'm interested in reductions between -20 and -83%. And then it will make a selection, a filter. And so then we click apply. And we've reduced now to 186 scenarios that fall within the specific greenhouse gas emissions reductions range. We have to go to select from list, and we click apply category and indicator selection. So that's what we were configuring at the beginning. Click apply. It's not entirely configured, but I'm going to change it to world. And I'm going to change this one here to where are greenhouse gas emissions? Here we go. Kyoto gases. Ooh, there we go. So I've selected negative values for the greenhouse gas emissions reductions, which actually means that they are increases. So those would be the ones that I think that we chose, from about 20 to 80% increase in greenhouse gas emissions reductions between 2050 and around 2050. Okay, so I'd really encourage you to explore the category and indicator selection, because it makes things quite fast. Lastly, in terms of the workspaces, I'm going to go back here, and maybe you're ready now to create your own new workspace. This is comparatively simple. So we'll click on create a new workspace and start by clicking on, nope. Sorry about that. We'll start a new one, create a new workspace, click edit workspace. We can put a new name, put the description. One thing that's important is that all your workspaces are automatically listed as private, but if you select unlisted, then you can share it with other colleagues. And so you click here on this key button, you get a unique link, and anyone that you share your workspace with that uses this link, they'll be able to view your workspace. We want to save it, so we're going to click here, save to server. And now we're ready to start with our new workspace, and then we get the new panel configuration. Make your changes, select your scenarios, and always remember to click Save Workspace here. You can also export it, for example, to a PDF, and you can also clone your workspaces and edit them and save them and come back to the website and continue your work. Every time that you make changes to a panel, just in terms of the visualization or even just the title, then you need to click Save. Otherwise, your changes may be lost. Lastly, I'll show you the documentation and the downloads pages. So the documentation page has lots of information about the model, scenarios, variables, and regions, and also the metadata. Unfortunately, we couldn't collect all information from all models, but I'll show you examples. For example, on models, then we see nice complete information that the models should ideally have something about documentation and the regional coverage. We can see also Blues Brazil, which is relevant to this region, also has a nice description and a link to the integrated assessment modeling documentation wiki. I think IMACLIM Argentina also has information here. Scenarios, in many cases, and this depends, is often a link to the relevant paper where that scenario was published. It's not always complete. Sometimes there is more information about the scenario, but in minimum case, it should be something about the project and a link to the paper where it's published. And then similarly with the variables, we have descriptions. This is an important variable, the magic 50th percentile temperature, and we can see the definition and the unit of that variable, global mean surface temperature, used for scenario categorization. For those of you using the metadata also to select, so this is how we could filter the scenarios in the scenario selection. Then we can see that category name here is the climate outcome from the climate assessment, see chapter 3 and annex C for details. And lots of the full list of metadata that's in the database. Lastly, in the downloads, so there's lots of information on the downloads page. There's also a lot of information on the about page. If you're using the database, please cite it, and please make sure to read the license. So we cannot republish the database in other places in full or large parts of the data. If it's small parts of the data used to make a figure for a paper, that's okay, that you can make that data available. But if in doubt, please get in touch with us to discuss it, because sometimes there are updates to the database, and to be careful that people are using which version they're using, or using the most up-to-date version. We're now on version 1.0 was what was released after this summary for policymakers, and version 1.1 was came out about 6 months ago. And this is where, right at the bottom is where the files are for the data download. So we've got about 9 or 10 files that relate to version 1.1. The ones with most of the data relates to here, world, R5, R6 regions. If you're interested in Brazil and Latin America, then probably look through this one with R10 or the ISO 3, that's the one with the different countries. We've also got the metadata indicators that is likely of interest to people here. Lastly, on the About page, lots of information, including the database process and where the data was used in the report. I would encourage many people to look at Annex 3 of the Working Group 3 report. It has lots of information about scenarios and database. We have tutorial videos, information about the climate assessment, and also acknowledgements. None of this would have been possible without big contributions from many lead authors across many chapters in the Working Group 3, and also Working Group 1, who collected the scenarios, checked them for quality, and also did post-processing of the scenarios. Also financial and institutional support both from IIASA, Integrated Assessment Modeling Consortium, and European Commission, that supports a large team working here at IIASA and other places in processing these types of data. And also finally, encouragement support and a working agreement with the technical support unit of Working Group 3 and TG-Data, and many scientists who worked in the 6th assessment report. So this has been a culmination of many years' work, and it also includes the contributions from many scenarios. So many modeling teams across the world who have submitted their data and also supported the lead authors. We've radically increased the number of people participating in IPCC process and a diversity of modeled scenarios, and I hope that this will continue. And the database also helps present this information transparently. But it doesn't stop with the IPCC process. So now the fun starts, and it's over to you, researchers, and I think analysts, policymakers. We hope this becomes a useful resource in your day-to-day work. Use the data, and I know that it can be messy and complex, but if you have questions and difficulties, or if you're using it in interesting ways, then we'd love to hear from you and get in touch. Thank you.
Thank you very much, and have a nice week. Bye-bye.
Okay. Thank you. Thank you. Bye-bye.
Thank you, everyone. Bye-bye.
Thanks, everyone.
Thanks, everyone. Bye.
Bye-bye.